Yeah, we might have a forum, so we can even start a few minutes early. So, welcome along to SSDT for Visual Studio. Hi, my name is Hannah. I am a friendly developer. Please do not throw tomatoes at me if you're a DBA. I promise I'm here to help. So just out of interest, those of you who are in the audience, raise your hand if you consider yourself a DBA, a database engineer, a SQL developer, anything sort of in that area. Cool. All right, raise your hand if you're a developer in sense like a .NET or front end or those sorts of things. Wowzers, okay, right. Okay, good, got a good, nice mix. So I'm going to insult both groups equally so that we've, everything's fair and even Stevens. No. So I'm a .NET developer by background, but I actually really like all things SQL, and so this is something I'm very passionate about in the sense it combines those two in terms of making two traditionally separate disciplines actually come together. So as this is a 200 level session, I'm kind of assuming that you guys know what SQL Server is, that you can insert data into it, that you can manage data and all those sorts of things. You know what SQL Management Studio is. And you might have even heard what SQL Server Data Tools is, maybe even read an article or two, maybe even installed it and gone, I don't get this. So what I'm going to do is give you a bit of a kickstart into actually how you can get started with it and a couple of tips and tricks what it's all about if you haven't heard about it as well. So what is SSDT? Who here hasn't heard of SSDT? Well, this is the first that they've come to. Okay, we do actually have a couple. All right. So it's SQL Server Data Tools. It's basically an extra functionality inside Visual Studio. And it's designed, the slogan is build, debug, maintain, and refactor databases. Now, the really important note here, and it's probably one of the most common misconceptions, is it's not a replacement for SQL Management Studio. Not in any way, shape, or form. Completely different set of functionality that it provides. So a lot of people I know have reviewed SSDT, and they've said, oh, I don't know why I'd use it when I can use SQL Management Studio. Totally different use cases, and I'll show you how. Now, it's declarative. If you don't know what I mean by that, I'll show you in a little bit. And it enables you to have a project inside Visual Studio and put it into version control, which is very, very powerful moving forward. So why would anybody care? Is it not, is it some new fandangled technology that's going to make your job harder? Why would you actually want to invest in this? So if you take a look at how we treat our code, especially as .NET developers, a lot of these are fundamental concepts to our role as a developer. We have source control. Our code is deployable in some repeatable, usually automated way. We have versioning. We know who made what change when. We usually have unit testing in some form, depending what you work on, or some form of automated testing to various levels. And these terms of continuous integration and continuous deployment are increasingly common as people try and figure out how to get that thing deploying more frequently, more often with more automation, and that quality check around it. And those are all things that, as a developer, you've heard before, right? That's, yep, nothing new there. Move over to databases. What do you mean source control for databases? What do you mean automated testing for databases? Are you nuts, right? Versions of databases, well, production is the version. If I want to know what the schema looks like, I ask my DBA to tell me what the schema looks like on production. Does that sound familiar? Yeah, a few nods? Okay. So we've got these two very disparate worlds, and yet if we look at what we do as a job, most of our jobs are running applications that talk to databases. So why the disparity, and can we resolve it? So this is what most people are doing with databases. Hands up if this is you. Nobody. One? Couple? You wrote a script, you run it on the server. Yay. And then Bob goes on holiday and he had the only copy of that script. No. Not exactly the best database. The database is a pet. It's being well-watered, well-maintained, but it's actually not in the most optimal state. Now, if you're lucky, you might work in an organization that also puts the same change into source control. Who's in this sort of situation? Cool. But you notice there's no link between source control and database there, right? So somebody can make a change, not put it into source control, but release it to the database. Or, as what most commonly happens, you're in production, your DBAs thinks, oh, that index is performing really badly, they do a bit of a hot fix, and it never makes it back to source control. People had that happen before as well? Yep, nods, excellent. So you end up with this kind of two paths that you're having to manually keep in sync. That doesn't work either. So what if you wanted to answer this question? So who here can tell exactly what their schema looked like a month ago? Stick your hand up. 1, 2, 3, 4, yeah. So what if you wanted to reproduce a bug that happened in the last release? And again, we work on applications that are heavily database dependent, and often that depends on knowing exactly what the database looked like. Are you seriously going to go down to your DBA and say, hey, do we happen to have a release that's, backup that's a month old? They're probably going to turn around and kind of give you a bit of a laugh. No, we only keep 2 weeks worth of backups, right? Or whatever. Do you really want me to get that from the tape backup and, pay a $100 recovery fee or whatever for the one table that you've... No. So this isn't particularly useful when you're working with databases. Similarly, you can't really easily have variations of databases. So again, if you're wearing your DBA hat, you might be playing around with maybe re-indexing, the strategy you're using for index or some sort of performance tuning. And you might be working away on maybe another copy in production or a local copy of the database. And then and you're working on that, and then you go on holiday. Where's that work stored at this point in time? On your machine, probably, or on a server somewhere that nobody else knows about. Not easily necessarily a version that somebody else can pick up and go, yeah, cool, let's roll this into production. Or you've emailed that file to somebody because that's your handover process. Yeah? So not particularly straightforward to have variations of the schema under some sort of centralized control. And the last part, which always is a kicker, you guys are highly trained, right? You've all been in the industry for X many number of years. Many of you will have done formalized qualifications. And you are sitting there handwriting an alter statement to add a column to a table. Seriously, that's not the most nice part of your job. There are better things and more interesting things for you to do with your time. If you're a DBA, you are trained at at all sorts of other things, server maintenance, database maintenance, performance tuning, all of the other things that are sort of far more important. As developers, you've got better things to do with your time as well. Honestly, there's way more things in the .NET framework that are far more interesting than this stuff. So let's take it out of the equation. Let's consider for a moment that we can commit our changes to source control. We can do a build. Now, if you don't know what a build is, I'll come back to that in a bit, but if you're a developer, you'll know what a build is in Visual Studio. And that results in the deploy. That's the thing that we deploy. There is now a software development lifecycle in place for a database. No way. So this might sound familiar to a few of you. This used to go by another name. So if you look at the 4 pillars of SQL Server, so reporting services, analysis services, integration services, and the database engine, some of you might be familiar with the Business Intelligence Development Studio, known as BIDS. And there was this thing, Visual Studio Database Edition for Professionals, also known as DataDude, or somebody called it DataDudette the other day to me, also known as VSDB Pro, it had like 10 different names, right? And this is what SSDT has replaced. So SQL Server Data Tools has replaced these tools. And just to be really clear, though, there are still 2 versions of SQL Server Data Tools. One which, if you look online, you'll see as SSDT-BI, which, funnily enough, stands for Business Intelligence. And one of which is SQL Server Data Tools, which is for the database projects, which is what we're going to be talking about today, your schema management. Some key stats. It's really important to note SSDT is available from Visual Studio 2012 onwards, so it doesn't support 2010 and below, which is what database projects were for. But some really important differences. It used to only be, the original version used to only be available in sort of the more expensive editions of Visual Studio. That's no longer the case. You can even get it in the community edition of Visual Studio. It's free, it's frequently updated. And when I say frequently updated, I don't mean like a service pack every year. I mean like they release multiple updates, close to monthly in some cases. It's actually quite incredible the rate at which they're adding features to it. So it's well supported by Microsoft. And it still supports from SQL Server 2005 right up to Azure. There's asterisks pointing out that with some of the newer versions, like Visual Studio 2015 and SQL Server 2016 out, there's a little bit of, you have to check which version of Visual Studio you're working with SQL Server. That will eventually get ironed out. It's expected to come out next month so that every version works with everything. But for the moment, there's a little bit of just check which version you're working with which. So, what's new? What did they do with it? Look, the short version is they renamed everything. Pretty much all the major things that you cared about if you'd worked with database projects got renamed. And they simplified a huge amount. There used to be multiple project types. You had to know if you were developing for SQL Server 2015 or 2008. There's just one project now. It's a database project, that's it. And they just removed a lot of noise, I think is the best way I describe it. So your projects are simplified in a big way. We'll see that in a moment. And a lot of the enforced rules and regulations about projects and structure have been removed. So you can do more what you want with the project. couple of two new features. One is an editor, which we'll show off, and the other one is live database debugging. So this is the ability to actually attach to a local instance of SQL Server and actually go through and debug, which again, if you're a .NET developer, is totally normal, but not for a database. So this is extending that into your store procedure, seeing what it's doing as it goes through. So enough talking. Let's actually spend some time going through demonstrations, because that's far more interesting. We all love a good demo. Okay, so just to kick us off, this is Visual Studio 2010. And you can see here we've got a database project and a server project. So what I've done is I've actually taken a real database. This is an excerpt of the DBA Stack Exchange site. They publicly make the information available online and the data that goes with it. So this is a database that's about 1 gig in size. It's got real data in it. So this is their schema. I've added a few things just to make it interesting, but it's a real database. So this is what you'd see in 2010 in the old way of database projects. And your server project would, funnily enough, have server-level objects, logins, link servers, etc. And your database project would have database-level objects. Hopefully I haven't lost anybody at this point. And so you can see if we drill down, there's all these folders. They're actually all empty. Almost all of them are empty. We've got a schemas, and there's a DBO schema, and then there's a tables folder, and then finally we actually get to the stuff we care about. And you'll notice that it's split out the keys into a keys folder and the constraints into a constraints folder. And so if you actually want to know what a table looks like, you've got to look at about 5 different places. It's really annoying. So enough time talking about the old way. The new way, well, hey, much cleaner, one project. This is the exact same schema in SSDT. Same table, same definition, everything. So we've got one project that contains server-level objects as well as database-level objects. So really much easier to see what's going on. And you can see now some interesting things like, if we take a look at my user, in the same file, we've got the user, the login, the tying of the user to the login, and the grant of the connect. So actually, I can see everything related to that user account in one place without having to jump around. So this is much, much easier to work with. Now, if I wanted to import a database, if you happen to be in a scenario where you haven't got something in the old version of database projects, there is, funnily enough, an import menu here. You can import a DAC pack. We'll go through what a DAC pack is in a little bit. You can point it to a real database, and you can import it from SQL scripts if you've scripted out a database, and it will get it into this format. So let's have a look at actually working with this thing. So I'm going to have a look at the user table. So this is the new editor that they've provided. So originally in the old database projects, it was just a SQL file, and so you had to be pretty much a SQL pro and know how to script everything manually if you wanted to make changes. So now it looks a little bit more like SQL Management Studio. If you're not, you don't know the exact syntax to create a new schema, it can help you out. And it comes with a lot of the added benefits that as developers or .NET developers, you would expect to be here. So I'll show you an example. If I scroll on down to the bottom, and for some reason, my colleague has told me that there's a data type of int2, right? And I believe them for a silly moment. I can add int2. So first of all, we've got IntelliSense. It tells me it's an invalid thing. If I ignore that, and I do a build, you'll notice I get a build error. Now, building, again, if you're a .NET developer, building is very much a normal thing that you do. But for DBAs, this is kind of, well, what am I building? What's it actually doing? And so it's basically parsing all of these files that it can read. And it's parsing them. It's pretty much exactly the same as hitting the parse button in SQL Management Studio. You know, it kind of does a syntax check. That's exactly what it's doing. And so it gives you some feedback. Obviously, it won't check that your scripts do what you want them to do. That's your problem. But it will check that they're syntactically valid. So I can come back and I can change this. And we get a couple of things that will help me add a column. So if I want to add a new column here, I've decided I want to know, I want to be a bit creepy, and I want to know when people were born on Stack Overflow, so I can start doing nice little metrics on people's age. So I'm going to add a date of birth column. And it helps me out by providing some useful data types. So I'm going to do a date time 2 because I've been told by my DBA that that's a good thing. And you'll notice that each of the editor panes is updating as I make those changes. And it doesn't matter where you want to work. If you prefer working in SQL, I don't need this GUI. I know how to do this all by myself. That's great, You can work in whichever one suits you. So I've now got a new column added to the table. If I build, I get a succeeded message. You'll also notice that I get some other messages. Apologies. It says writing model, and then talks about a bunch of files it's spitting out the other end. So let's have a look. I've already mentioned DACPack probably about 3 times. So what is this DACPack thing? So if we have a look at the project on disk, we'll see that there's a bin folder. Again, .NET developers, this should seem really, really familiar. Bin folder, debug folder. And this is what it's built. This is the output of an SSDT project. And the interesting thing about this is just like a DLL in .NET world, you can pick this up, move it anywhere else, and it contains all the information you need about that database. You could email it to another colleague, and they could look at the definition. And it becomes really powerful later on. Now, you might be wondering why there is a, and that's the DACPack file right there, that one there. DACPack is the almost zipped, if you wanted to think about it, version of that database. Now, you might wonder about the DLL and the PDB that's in there as well. And the reason for that is, any of you work with SQL CLR with your databases? Yeah, a few people. Okay, so in the old version, there was a separate project for SQL CLR, a separate Visual Studio project. This is, again, all in one project, right? So this is spitting out a DLL with the SQL CLR function. So that's your DLL that you'd go and install on your server and deploy. So everything is in one place to do with that database. So you've got your DACPack, which is your schema, and your DLL and PDB, which is your SQL CLR functions. So that's pretty tidy, nice to use. Another quick note is if you, I've talked about the IntelliSense and the GUI, but the other thing that comes out of the box is if you want to add something new, a foreign key, an index, anything you actually possibly want. If you go File New, there are literally hundreds of templates of different objects in here, all of which are essentially pre-scripted for you. So if we want to look at a credential, it gives me a pre-baked template on how to work with that. So if I can't quite remember the syntax to work with that. So just delete that. Cool. So I'm actually source controlling this database, this project, sorry. And you can see here I'm using Git. If any of you aren't familiar with it, it's fine, no big deal. It's just source control by another flavor. And you can see here I've already got some history in this repository of changes that have been made. So you'll remember that we added a new column. So I'm going to commit this as a change, add new date of birth, because I want to be creepy. Cool. All right, so great, we've made a change. It's a hypothetical change. It's sitting on my disk. It's not anywhere useful. It's not in production. What do I do? So then we get into publishing. So if you right-click the project and go to Publish, you get a dialog box that allows you to specify where you want to send this to. So first of all, obviously a database connection string. Now I've got a local database here, which I'll quickly show you, just to prove that I'm doing this for real. So here's my dba.stackexchange.com database. And I have a look at my database tables, the user table, and the columns, and scroll down far enough. You'll see that there's no date of birth there. Okay, so this is an older version of the schema. So if we go back here and we say, well, the database connection string I want you to use is my local server, this database. And there's a huge amount of options here. I have to point this out. Under advanced, if you're thinking, I want to ignore store procedures, I want to drop certain types of objects, there are thousands, or hundreds probably, of options under here that can control the behavior of your deployment. So there's quite a lot of customization you can do here. So what I'm going to do is I'm actually going to save this. So there's these 3 buttons down here that mention the word profile. And this is where we get the term publish profiles from. A publish profile is a pre-canned set of settings to try and deploy your database somewhere. So it's usually got your connection string and a minimum, but it could also be other options that you want. It could be, you could have one for each environment, one for your local machine, one to deploy to your testing environment, one that has all the right settings to deploy to production because you don't want to alter objects under CDC and you don't want to compare logins and permissions because you want production to set those sorts of settings that might be relevant to you. So we can save this under a name. So I'm going to call this local because it's referring to my local database. And I'll hit publish. And so we get a nice little progress sort of menu thing going on. Green ticks are always good. Clearly you've done something right at this stage. You may not know what, but you've done something right. If we have a look at what it's done, it's actually generated a script behind the scenes. Now there's a bunch of templating at the top. Don't let this throw you off. This is using a language called SQL Command, which is actually available in SQL Management Studio if you haven't played around with it. It's quite interesting. It's just kind of a basic scripting language for SQL. You can set variables and things. So it's setting a bunch of variables like the name of the database we're deploying to. That SQL command syntax is supported, and then we get down to the part we actually care about. Alter table, add column. Hey, that was a lot easier than having to handwrite that and misspell the table name 3 times and, forget the key word that for some reason you should always remember. But notice it did something else as well. If we scroll on down, it's picked up something that I forgot. The user table is used in a view called user badges. And it's remembered that, hey, you've added a column over here. You probably need to refresh the view. Did you forget that? Let me take care of that for you. I'm your friend. Okay? So this is where we're getting rid of human error. Instead of relying on humans to remember this sort of stuff, the tool is taking care of it for you. So the way that it works, you might have noticed that there's a little bit of a disparity here. If you look at this user.sql file, it says create table. And if you look at the script, it says alter table. And those of you who work with databases day in and out, whoa, you can't issue a create table. Whoa, where's your if exists? That thing might exist on the server. Don't, slow down. Don't be ridiculous here. So this is the key as to how SSDT works. The way that it works is it's declarative, right? It comes back to the word that I mentioned at the beginning. You declare the way you want the database to be, as if it was a blank slate. So everything's written in create statements, or the equivalent thereof. It works out, when you point it at a destination, what the difference is, and therefore what instructions need to be issued against that database to make the target look the same. So it's all about, it has an internal hypothetical model in memory, basically, of what the database should look like, what does it need to do to affect that change. And so we get this calculated script of alter table. So, once again, we're going to commit my changes because unlike the stereotype of developers, I'm conscientious about committing regularly and having useful commit messages. Okay, so we're adding changes. This is going well. So next up, we've looked at how to make a change and how to force that change into the database. Oh, I didn't actually show you that. Apologies. If we go and look at the database now, having run a publish, columns appeared. And I didn't manually run anything. Yes. Good. But what if I like to work the other way? What if I'm not really comfortable working in Visual Studio? I'd actually rather get the schema right in the database first, and then when I know it's working and my app's working against it and everything's aligned, then get it into Visual Studio. Maybe that's just the way I prefer to work, right? That's fine. Got you covered. It's all good. So we are going to add a column to another table, which is post. So at the moment, we've got a couple of dates in the post table. We've got a created date, and we've got a last activity date. But I want to be able to mark when it's been deleted. If a moderator comes along and deletes the post as being off topic or offensive or something, I want to know when that happens. So I'm going to add a deleted date to this. Now, I could go new column, but I'm going to pretend for one moment I actually can write SQL without a hand. Sorry. So just to prove my street cred, right. So we're going to add a deleted date column, which is a date. See, this is why you don't manually write scripts. You misspell things. Which is a date time 2, and it's a nullable column. Cool? Everybody happy with that? Excellent, wonderful. Got a few nods. Ooh, that was good. I was worried that was going to have an error in it for a moment. So we've added a column. We refreshed the column list. Yay, we've got a deleted date column. And my real database on my physical SQL Server instance. So how do we get that back into Visual Studio? Enter something called schema comparisons. So I'm sure a lot of you have probably used tools which allow you to compare schemas and see the differences between them and potentially apply those changes. So SSDT comes with exactly the same set of functionality. So we're going to right-click and go to schema compare in our project. And we can define what it is we want to compare. And this is where we start seeing some really cool abilities. So we mentioned a DAC pack, and I said, look, you can take that DAC pack and you can do anything you like with it. You can email it to your colleague overseas, and they can see exactly what the database looks like. Your schema comparison tool actually is able to read from a number of different sources. So you can compare a project to a project, a database to a database, maybe testing to production or something like that, or DAC packs as well, or a DAC pack to a database or a database to a project, or any combination thereof of those three things. This becomes incredibly flexible, right, in terms of how you want to use it. It's not just about one way from a project to a database. So anyway, I'm going to take my local database as the source, and I'm going to take my project as the target, and I'm going to run a compare, and pretty much like every schema comparison tool that most of us have used, it's going to show me the schema differences. So it's saying, look, there's a change in the post table. If I expand this out, it's telling me that there's an added column called deleted date. And if I click on the object, it'll actually give me the SQL script and show, the SQL that would theoretically generate and the line that's going to change. And I can go, yes, that's what I want to import. Now, if I had multiple changes here, they'd list up there, and you can see I can actually unselect it. So I can selectively apply changes or import changes or affect changes. I don't have to do everything. I don't have to make the target look like the source. I can do partial updates. So I'm going to say, yes, I want you to update my project in Visual Studio to have that new row. I'm going to say update, and yes, I want to update the target. And it's going to process in the background. Target update complete down the very bottom left there. And if we go back to the post table, you see it's got a nice modified red check mark, if you can see it there. And if I scroll down, we've got a deleted date in the project. Yay. No more manually copying and pasting SQL. Cool. So again, I'm going to, I am going to commit this. Help if I save first, wouldn't it? Here we go. Oh, apparently I can't read my own screen. That was the right file. Okay, so I added a column, so added, deleted, date. Okay. All right. So that's all well and good. That's very kind of vanilla, right? We've made a change, we've published it to our database, we've made a change in the database, and we've imported it. And you're all thinking, yeah, but my world's way more complicated than that. Yeah? Way more complicated than that. So I want to show you a few things that most people who, when they start with SSDT, kind of hit as roadblocks. And it comes down to understanding what SSDT is trying to do behind the scenes. And hopefully, a few of these might trigger some, that's kind of where I went off if you did have troubles with it, or at least help you understand in the future, if you do try and have a play with it, what it's trying to do. So if we have a look at my, my post table, I don't like the look of it anymore, okay? So we've got a deleted date down the bottom, and we've got a created date up the top, but I want them to be together. That's a nice aesthetically pleasing table for me, right? Group common columns together. So that's easy. I'm just going to select this row in the T-SQL editor down the bottom. I'm going to cut it, make it look tidy, as if I care about tabs. And I'm just going to move it down in front of deleted date. So you can see I've now put created date and deleted date together. Cool. Any problems? Yeah. So yeah, there's a couple of people that have clearly played with this. So let's have a look at what it actually does behind the scenes. So let's do another publish. Now what I'm going to do here is I'm not going to do a publish. You'll notice there's a generate script button. So this is the hypothetical. Go through the motions of calculating the difference and generating the script, but don't run it. Okay, I want to see what you think you'd do. This is really useful if you want to see it before it affects any change. So we're going to generate the script. And if we have a look, the templating that we saw before, and if we scroll on down to the part, whoa, drop. Hold on, I didn't drop any constraints. More drops. Okay, now I'm getting nervous, getting really nervous, increasingly getting nervous. Temp table. What do you mean you're creating a temp table? Why are you doing this? And you keep going down, and you realize that actually it's creating a temporary table, copying all of the data across to the temporary table, and then wait for it, dropping your old table. No, that's not quite what I meant to do. right? Now, the reason here is it's very, very simple. If I told you, as somebody who is a DBA or a developer, I want you to change the order of the columns in the table, what would you write? A script that looks exactly like this. So SSDT will do exactly what you tell it to verbatim. You think you've made a cosmetic change, you've told the SSDT to reorder the columns. So have a think about that. If you're finding that SSDT is doing something and you just think, why is it doing this stupid thing I don't understand? More than likely, it's actually doing what you've asked it to, but you have implicit knowledge that it doesn't. And let's take another look at there's another example of that that really commonly happens too. So let's just quickly undo my reordering. Yes, thank you. The way it was, it's fine. So the other one that happens, you might notice that all of my other columns have a UTC appended on the end. A good naming syntax. And somebody points out to me, hey, you know that deleted date column you added? It's missing the UTC on there. Ah, I'm such an idiot. Okay, so in production or your database, you just go SP rename, right? Easy. But remember, we're trying to do this the proper way. So what are we going to do? Well, I'm going to come in here. I'm going to say, oh, that's fine. Look, all I need to do is this. Done. Let's publish that out to my database. Again, let's have a look at the script just before we push the big button. And if we scroll past all the templating, oh, no. We've got a refactoring log file. Now, here's a trick. Let me do that again for you, but in a different way. I'm going to explain what a refactor log is in a little bit. I'll come back to you. Come on. You're being a pain, sorry. Okay, so let's do it one more time. You'll notice there that time I changed it in the editor up the top. And I did get an SP rename in the script that was generated. What if I change it down the bottom? And I do a publish. Okay. Drop. And an add. Not what I wanted. Why? Because SSDT has no way to know that those two columns are actually the same. As far as it's concerned, there was a column called deleted date that no longer is there, but there's now a column called deleted date UTC that needs to be added. Okay, so you need to tell SSDT what to do. So this is a trick for young players, is that if you edit things down the bottom, it won't automatically be able to figure it out, but you can manually tell it. So if we instead right-click in the editor down the bottom and go refactor, and hopefully you're going to guess where I'm going to go next, rename. And funnily enough, you enter the name you want to rename it to. Now, actually, ironically, I'd actually recommend you do this anyway for other reasons, because this is kind of cool. It will go through and find any usages of that column and go, hey, do you actually want to update those things? So if I had store procedures or views or anything else using them, functions, it'll say, did you mean to include these? And it will show them in that list, which is actually really handy. I've only got it in the table at the moment, so yes, I want to update. And you'll notice here, this refactor log being created. Now, if you can wade through the XML, hopefully you can work out the key pieces of information. A column called deleted date in the post table is being renamed to deleted date UTC. Key parts that you care about. This refactor log file is very, very important. This is what allows SSDT, next time you do a publish, to equate those two columns that are seemingly unrelated. So check that in, keep it, don't drop it or delete it. It's now part of your project, right? And it'll enable SSDT to be really smart about your publishers. So again, if I generate the script, you'll see what we saw the first time when we edited via the GUI editor as opposed to the text editor. And we'll see exactly what we'd like to see, which is an SP rename instead. Much safer way to do it. So again, as I said, if you're seeing this kind of odd behavior, it's not quite doing things that you expect, think about what you're asking it to do. And whether that's actually what you meant to ask it to do. So I have three new files this time. Rename the deleted date column because my DBA told me to. says every developer in a commit somewhere ever, right? Okay, so we've now got through some of the normal sort of traps, renaming, column order. The next one is reference data. So those of you who stuck up your hand and said, I know what my database looks like a month ago, stick up your hand if that includes what your lookup data looks like as well. 3 or 4. Okay. So if you think about it, just taking a step back, your reference data, lookup data, whatever term you want to use for that static data is just as important a definition of what your database looks like at any point. Think about your applications that read that data and use it. Even data that is reference data usually changes over long periods of time, right? You might have another office open in another country and you need to add a new row to the office locations table. And that might fundamentally change something about how the application behaves, maybe what your testers are seeing, maybe what your customers are seeing. So if you're trying to reproduce a bug a month ago, it's not just the schema you need to care about. It's also the lookup data that dictates the behavior of your application in most cases. So how do you do lookup data or reference data in database projects? And the answer is easily. So in SSDT, there are special types of scripts you can add. So if I go add script, you'll see there are 4 types here. There's a post-deployment, a pre-deployment, a script that's included in the build, and a script that's not included in the build. And really I'm going to focus on the first 2, post and pre-deployment. Now funnily, hopefully from the name, you can work out when they get executed. One's after deployment, and one's before deployment. Cool, all good. But we're going to look at post-deployment. Now, when we talk about deployment in this sense, we're talking about when the schema changes are affected, right? So that script that we keep looking at before, is this script that we're creating now going to execute after the schema changes or before the schema changes are affected? So depending on what you're trying to do, you might choose one or the other. So I want a post-deployment script. And in it, I'm going to cheat. Here's one I prepared before the show. I've got some post types. So this is some reference data. Now I've taken this directly from the database. If we go to our database and I show you what's in the post type table, you'll see 8 rows. Hey, cool. So I can do an insert. So this means every time I do a deploy, it's going to do whatever calculated schema changes it needs to do, and then it's going to run the script verbatim. Now this is a key difference. Remember I said everything else is a create statement? This script is not a definition of an object. It is going to run it as you write it. So this is literally as if you've handed a DBA a script. So you need to be thinking about the implications of that script. So with that in mind, is this going to work? It's going to work the first time. It's going to work the first time real well, and then the second time it's going to error out on a primary key violation, because it's going to insert the same data again, if I've got a primary key, that is, on my table. So probably not the best way to do that. The alternative, however, is nice and easy. You can use upserts instead. So this is an alternative using a temporary table. It's exactly the same data, it does exactly the same operation. So you can see here I've declared a snapshot table and I've inserted the same data. I insert anything that's missing from the destination table. I update anything that's already in the destination table. And I delete anything that is in the destination table but isn't in my list of things I know about. Easy, right? Straightforward. Now you could use a merge. If you're familiar with the merge syntax in T-SQL, that's absolutely a possibility. I haven't used the merged here because we tend to find that its locking behavior, especially if you're running it in production, isn't quite necessarily what you want. So that's one of those conscious choices that you need to make about how you do the post-deployment script. So this tends to be a pattern that we use. And just to show that it works, I'm going to add another one. So there's going to be a site notice type post that is a new piece of functionality that we add. And again, if I do a publish locally and rerun my query to retrieve all the rows, we've got 9 rows. Yay. But this is now version controlled. So if I go back to my project and I save and I commit, I now have history of when the reference data was updated. So not only do I have schema what did my schema look like a month ago? I know exactly what my reference data looked like a month ago, what rows were in there to dictate the behavior in the application. Okay, so add reference data. So we're going well. We're establishing a nice little history here about the database. And those of you who are used to working with source control will realize that this opens all sorts of possibilities. I can go back to any point in time, check out the definition of the database at that point, and have an exact, accurate copy of the schema, the data, and anything else that's supported to get this thing running. I can instantly deploy that anywhere, and then I can go, hey, cool, I now know what that bug was all about, because John added that column when he really shouldn't have. And also, the other part of it is the audit trail, right? So we've got a clear, now admittedly I'm the only developer on this project, so it's pretty easy to see who to blame, but we've got a clear trail here of the changes being made, when they were made. I can look at any of the details around looking at the diffs. For example, if we have a look at adding the view count column, that's when I added the column. So you know exactly when it was added. None of this mysterious, it might have been that week or that day, or there was a change control form somewhere that should say what columns were going to go out. I can't really remember. So you've got full audit history about what happened, and you can understand why something's changed. And of course, if we could be all being amazing, wonderful developers, our commits have links to the issue or the ticket or whatever we were working on, and you know why that change was made, because we all do that, right? Yeah, sure. Okay. All right, so the last piece of the puzzle. For many people who are DBAs, working in Visual Studio isn't something that comes naturally. It's a bit of a foreign territory. So if you're sitting there going, there is no way I am installing Visual Studio on my machine, get away. That's the .NET Devs world. That's okay, that's all right. We got you covered as well. So I mentioned in the original slides, you might have seen something called SQLpackage.exe. And if you've played with the old version of this before, you'll know that it used to be called vsdbcommand.exe, which really mostly scared DBAs even more because it had the words VS, Visual Studio, in it, and that just seemed like a no-go area for something that you might deploy to production. But this is a command line version of doing everything that we've just been doing so far. So let's have a really quick look at what that might look like. So I have another database here. I have a SQL Server 2016 instance running. And it's also got a DBA Stack Exchange database. But if we take a look at it, it has none of the changes that we've been working on so far. So if we look at the user table and the columns, you'll see it doesn't have the date of birth that I added. So it's an old version of the database. So let's just, for the sake of argument, say that this is our test or pre-prod or production environment, right? Something that now that we've iteratively made all these changes, we need to go and apply them all at once to the destination database. So instead of all your hand scripts that you've been carefully storing in a folder to execute them in order on release day, yeah, anyone? Yeah, okay, there we go, yep. Yeah. Let's not do that, right? Because that sounds not so good a use of your time. Instead, we can take this DAC pack, right? It compiles into a DAC pack, which is a definition of what we want the database to look like, and we can script and automate everything that we've done. So let's look at what they might look like. So there are actually about 6 or 7 commands available with SQLpackage.exe. I'm actually only going to go through 4 today, but I encourage you to look at the others if you're interested. These are the 4 that are probably the most useful to you off the bat. So the first one is extract. Now, I showed you before how you could import a project into Visual Studio, right? And the sources were a database, a DAC pack, or SQL files. And you might be thinking, there is no way I'm going to get Visual Studio to talk directly to my production database, which is sitting in some other data center that people don't have credentials to access, right? That's just not going to happen. And quite rightly, it shouldn't. But what you can do is you can run this against your production database. And what it will do is, funnily enough, export or extract the definition of the schema into a DAC pack. So it reverses the process. And then you can take that DAC pack, has no data in it. Let me be very clear about this. No data at all, just the schema. And you can send that to your developer who's aching to get this into Visual Studio and say, here's a copy of the latest production database. Go forth, let's start this process of using SSDT. And look, there's plenty of other arguments, but you can kind of see the basic usage here. Give it a connection string, or you can specify a server and a database name. You can also give it credentials if you need an alternative form of authentication. And you give it a target file where you want the DAC pack to turn up. So that's pretty straightforward. The other one hopefully, by now, you'll recognize what it's going to do, which is publish. This is the command line version of what we've just been doing with publish profiles. It's exactly the same thing. Going to go through the same steps. So you say publish, you give it a DAC pack, you tell it your target database, and it will generate the script, and it will execute the script. No different to what we did before. So if that is giving you the willies because you're a DBA and the thought of running an automated process against the production database just makes you want to sort of hide your head in the sand and go, there is no way, that's fine as well. So that's okay. That's what I want to go over the next two. So the next one is deploy report and script. And these are really, really good. So script, hopefully you can already guess what this does because we've actually, again, we've used it already. It's just script. So do a comparison, generate the script, spit it out to a file. But don't deploy it, right? Don't actually run it. And deploy report actually does something very similar, but I'll show you the output in a little bit. So what I'm going to do is I'm going to run the script and the report commands against my current DAC pack and compare it to saying that I, in theory, want to deploy to my 2016 instance. So you can see here I've got source file, which points to my DAC pack. Target server is my SQL 2016 instance, which is clean, has none of these changes. And I want to spit out a deploy report.xml. And while that's running, I'm going to do the same thing. You'll see here the action is script, right? Same arguments, exactly the same arguments. And it's going to spit it out to a deploy script.sql, funnily enough. Okay, so now that it's decided it's happy with that, let's take a look at what I actually spat out. So the SQL script, again, will look very, very familiar, has the same templating at the front, and you can see here it's going through all of the stuff that we have added. Here's our new column we added, the deleted date. Here's our date of birth. Here's the refreshing of the views that we did at the very beginning. It's collated it all into one nice script. See, no more folder with, scripts numbered 1 through 10. Amazing, right? But so the advantage here is a DBA can take that and go, yeah, that looks okay to me. Or, the point of you being a DBA or somebody who has expertise in SQL, actually, that's not quite right. I'd rather handcraft this part because I know a better way to do this. And that's great. But at least the mundane work has been taken out of you having to manually write the stuff that you don't care about. Yeah? So think of it as a starting platform if you have to. The other thing that it does, we talked about a deploy report. This is a high-level view of the exact same information. So if you're sitting there and you're looking at a 1,000-line deploy script, oh my gosh. Okay, so you're adding a column there, but you're dropping that thing over there. Oh, I have no idea what's going on. I give up. Yeah, sure, roll it to prod. No. So this is really handy, right? If you want to see the bigger picture, you can see a very high-level overview. Right, it's going to create a login. It's going to alter a table. Alter a user. Alter a table, post a user. And it's going to refresh a view and a procedure, which are a combination of the changes that I made. Sorry, the logins and XS1, that's clearly in my database wasn't quite up to date. But now I can look at this and go, yeah, that looks about right. That's what I was kind of expecting. I'm not reviewing line by line SQL, but what it will tell you is it'll tell you things that really send off alarm bells. It'll give you warnings. There's actually a section of alerts that comes up the top if there's things like potential data loss that will happen. And it will also tell you if it's going to do a table rebuild, which is probably the number one thing that you guys are worried about doing as an online operation. And it will flag those. So you can actually quickly scroll down. Yep, no table rebuilds, a couple of tables being altered. Seems sane, yeah? So imagine the time that can save you instead of you having to manually review SQL scripts. So SQLpackage.exe has actually very, very good documentation online on MSDN. This is the number one page that I end up going to frequently for all the different command line options. What I haven't sort of gone through is I vaguely mentioned the amount of customization you can do with this. So if you decide that you want to put your database into source control, but you don't want to include logins or the passwords or something like that, that's fine. You can exclude logins. You can include store procedures. You can customize it right down to the nth degree, and all of those are also available as command line parameters in SQLpackage.exe, as well as in the GUI version of published profiles. They're all exactly the same. nice overlap. So thoroughly recommend you have a look at that if you are thinking of automating it, or you just flat out refuse to install Visual Studio on your machine. That's an equally valid option. All right. So one note that I want to quickly go over, which is an order of operations. So again, this is understanding how SSDT works. It's really, really important to note that the script generation it does, which is comparing schemas and working out what actions it needs to take, is done before the pre-deployment script is executed. So if anybody's getting a grand idea, and they're in their pre-deployment script, I see this a lot. They write a pre-deployment script that tries to drop a column, thinking it will affect the schema comparison. Notice that the column's dropped and execute a different delta script. And of course, it's already been generated by that stage, so you end up with errors. So think about your order of operations when you're thinking about your pre-deployment and your post-deployment scripts. Are you trying to change the schema after it's already done a schema comparison, in which case you're more than likely going to end up with errors? It's a very common trap for people who are kind of new to SSDT and trying to find their way around. But congratulations, you made it. You made it through the demos. Hopefully you've picked something up out of this. So we've now got all of the cool ingredients to go away. We've got a database that's in source control. We know who did what and when and why. We can do any point in time understanding of the schema and its reference data. We've got a deck pack that we can pick up and move anywhere we like. And you've got command line tooling if that's the way you want to go. If you have DevOps in your company, it's something you can automate and include. Great, wonderful. You can spice things up quite a lot. These are 3 topics I'm not going to go into, but I strongly recommend if you're interested in them that you do have a look at them. You can unit test your database. Holy moly. You can do code analysis, so enforce coding standards and rules. And you can use composite projects. Those of you who are thinking, hey, I've got really complicated databases with interdependencies, composite projects really helps you solve that. And these are solutions to more real-world problems. And I strongly recommend you head along to, there is another SSDT session, which is on Friday at 4:30. It's actually in the same room by Darren Hall, called Advanced DAC FX and SSDT. If you're listening to this and you're thinking, hey, that's cool, I want to learn more, strongly recommend you go along to that, because it's a 300 level that will just take this to a whole other level of information. If I go back to the original idea, we've now got something in source control that we build and we deploy. And if you wanted to, you can take that even further. You could start looking at continuous integration. You could start having automated tests of your database. You could have it continuously deploy. Wow, that might be a novel idea. And the one thing I do want to spend a last moment on is talking about demos versus realities. It's always different watching somebody else give a demo, because you spend most of your time sitting there going, my world is not like that. It's not that simple. I have more complicated environments than this. So a really quick note. So I work for Xero. We have 40 different schemas that we manage. All of them are managed using SSDT, and all of them using the tools that I demonstrated here today. The DBAs use SQL package.exe to generate deploy reports and deploy scripts, and we automate all of our development to all of our 60-plus testing environments using this exact same process with some command line scripting around it, and it automatically deploys, generates the script and deploys to that testing environment. Production is the only one we don't automatically deploy, but we're still using the tooling to get us 95% of the way and get that good DBA check over the top. We've got developers who can start, they can click a local.publish.xml publish profile, they've got an instantly working database. The amount of time that saves is huge. And obviously we can see all the changes to our database at any point in time. And we have everything in there. We've got SQL agent jobs, we've got linked servers, everything that needs that database to fully function with the application is in source control and managed in source control. So as I said, go along to the, I strongly recommend the Advanced SSDT and DAC FX if you want to learn more about sort of this in the real world. Otherwise, this sort of stuff fits very much into the DevOps sort of automation tranche of things. So go have an idea about other ways of automating things, and remember that it is now possible to do that with databases, even if people don't openly talk about it. Thank you very much for coming. I hope you had learned something, and have a very good rest of the day. I'll let you guys go to lunch.